Hey guys, sorry about the delay. I started streaming without my microphone, so I had to correct that. So, it's time for part 2 of our software architecture topic. As you know, it's quite huge. I expect maybe 8 or 10 parts in total, so it's going to be a long journey. I hope you're doing fine today, and I hope you're ready because we're this close to continue to start talking about the software architecture in general, and not only about the role and not only about the soft skills required for the job. Last time reached the point, uh, we reached the 41st slide. So we are going to talk about common pitfalls for new architects. So let's continue. If you missed the part one, I strongly suggest to not watch me right now and start with the first part because they are super connected. The whole presentation is super connected and it's super important to watch everything from the start to the end. Good. So let's continue with common pitfalls for new architects. First order of business is to say that when we talk about a group of people, most issues or problems between some of the people in the group occur because of not using power correctly. Every single person has a level of power in every different group he attends. So, for example, I will have some power in my relationship, in my personal relationship, but when I'm outside with my friends, I may have a different level of power. And when I'm working and I'm in my job, I'm with my colleagues, then I have a separate level of power. So, depending on the group, I may be the alpha male of the group, or I may be a very shy, a very quiet guy. I may not express my opinion that much. So, different levels of power occur in different groups we attend. So, when we have an issue or a problem with somebody in a group, it's usually because we are not using power correctly. So, mainly speaking, there are three types of power when we talk about working, and when we talk about career, when we talk about professional experience, and so on. So the first type of main power is implicit power. This is the power which goes with your job description, the power which goes with your position. For example, if you're a team leader, most of the developers will listen to you. So if you say make a code review right now, they will do it. If you say implement the feature in this way, they will do it. Most of the time, of course, sometimes people may question you, but you're in charge. You're their boss, so they're going to listen to you. And for example, if you are the CEO of the company, most people will either listen to you and will do what you say, or they may leave the company because you're the CEO and they most probably won't be able to change that. So that's implicit power. The power which goes with your job position, job description, job role, and so on. Then we have granted power. Granted power is when everybody in the group approaches you as the leader even though you're not formally one. So, in a group, you're equal to these people. You don't have any formal power, you don't have any specific job role, but you grew as their leader naturally. Multiple reasons. There are multiple reasons for that. For example, you may be the most knowledgeable person, so everybody approaches you for advice. You may be the person who is more willing to share their thoughts, or you may be the person who comes up with the quickest solution. So, for some reason, people approach you, and this is granted power. So, the team granted you the power to be their superior, even though you officially are not. So that's granted power. Um, and mm, you may be the most charismatic person. You may just smile more often. You may be beautiful. Mm, That these are common reasons why people will choose you as their natural leader. If you think about it, in every team environment, always there is one person who is super helpful to the other guys, and usually people approach that person even though he is not superior to them in any way. He is not their team leader, he is not their boss, but people try to people most of the time ask him or her. So this is granted power. And finally, we have personal power. Personal power is the ability to absorb punches and recover. So it's the ability to stand back on your feet when you create a mistake, when a disaster happens, and so on. So imagine this. In one situation, I made a mistake. I'm feeling super guilty, and I may start thinking something along the lines. Oh, I'm such a loser. I'm such a failure. I made a huge mistake. People will judge me. People will think that I'm not suitable for the job. That's really bad. And more and more negative thoughts. So this would be very low level of personal power. Of course, most of the time people don't have that much low personal power, but still, some people beat themselves too much. And on the other hand, you may start thinking, well, I created a mistake, but I can easily fix it. I will just work 2 hours extra today, or I can just find a quick solution, or I can ask somebody for help, and I know I can do better next time. So I quickly stand back on my feet, even though I made a huge mistake. So this is higher personal power. Of course, if you always think that you don't make mistakes, if you don't analyze the situation correctly, that's not huge personal power, that's huge ego. But nevertheless, personal power is the ability to recover yourself when you have huge disaster. And most of the time, when we have any problem between different roles in a team, it's because there is a power imbalance. And we are now going to see the most common scenarios if we are architects. So the common issues when we're new architects, this is our first job, are the following. First, the lead developer loses trust in you. So you're the new architect, you make a mistake, for example, or the lead developer wanted to be an architect but they didn't allow him. So he may don't have enough trust in you. That's one of the issues. The second issue may be that the functional requirements are invalid. So you receive invalid functional requirements. The third issue is about the planning because often it may be too optimistic. And the final issue is the architect role holds no power at all. So these are the common issues you may encounter on your first architect job. Of course, there are many others. I will try to speak from my experience or from my friend's experience to analyze everything that may happen in your first software architect job, but still, these are the most common ones. Let's analyze them one by one. The first one, the lead developer loses trust. So here the situation is that the solution architect is actually being robbed of his implicit power. He or she wants her design, but the lead developer doesn't trust that design. The lead developer doesn't want to listen to the solution architect. So that's a problem. And here the lead developer is being robbed of his granted power. Because the lead developer wants to change the design a bit, but doesn't have the power. So an issue between two roles may occur because of this power imbalance. So in these situations, developers are also affected by the problem. Developers uh, don't know who to trust. Developers don't know who to listen to because the solution architect wants some design, but the lead developer doesn't trust that design and wants to do something else. So it's a problem. And this leads to endless discussions, and implementation starts to deviate from architecture because the lead developer doesn't want to listen to the actual solution architect, and that's not okay. So here, how to solve this, how to fix this? Well, it's the solution architect's job to make the lead developer successful. We covered that already because we want to create a better lead developer. So we want to create someone who will replace us in the future. We want to be the senior solution architect and the lead developer to be the junior solution architect. So our job is to create an actual architect from the lead developer. So what we can do here, we can empower the lead developer. So we can agree with his design decisions if they're correct. So even though we think there is a bit better way, we can agree with the lead developer's solution. If the lead developer solution actually does the job perfectly, then there is no reason not to listen to him. Uh, we should always present a united front. We should always think about the other person and put ourselves in his shoes. So we should always consider what he is thinking about, because we may have the high-level overview of the architecture, but the lead developer may have some tiny little detail that helps him understand that our design is not that great. So we should always think about both sides. We may want the perfect design, but there may be some limitation in the current implementation. So we should listen to the developer, to the lead developer. Of course, if it's our first job, we may make mistakes. We may not create perfect designs. It's completely normal. Architectural designs evolve in time, so it's completely normal to have such problems. And we should be completely open to feedback because the lead developer may have a solid point about our design, and if we agree early on that we made a mistake, he may decide to trust us and he may help us create a better design. So he will become our friend. And if we decide to oppose him and say, no man, you're not correct, your design is wrong, listen to me, then he may start not listening to you at all, no matter whether your design is correct or not. So we should always be open to feedback, even though we are superior in terms of technical knowledge. People constantly learn. My experience as software architect uh, still has still still does not cover everything related to software architectures. I learn new stuff every day. I learned new stuff preparing this presentation. So it's a good idea to be constantly open to feedback. And of course, if we reach a point when we understand that our design is not that great, or if we see that the lead developer's design is also a good choice, we can change the architecture. Nothing is constant when we when we design things. Nothing is constant. So it's a good idea to be, uh, if not a friend, but it's a good idea to be even a friend with the lead developer. But even if we don't have friendships, or if we want to be more distant in our work environment, it's a good idea to be close to the lead developer because our work is closely related to his or her. Uh, and it's a good idea to have a solid connection between these two roles. So we should always listen to our lead developer and we should always discuss everything, of course, without losing the lead developer's trust. We shouldn't be soft, but we should be open to feedback. Okay, next issue, the second one. The second issue is when our functional requirements are actually invalid. It's quite difficult to realize this problem because usually mm, we we're not the guy who talks to the clients, to the end clients. So usually we won't be able to understand whether the functional requirements are actually correct or not. Usually, when we have an unmotivated functional analyst, we may have functional requirements that are quite invalid. So if our functional analyst is unmotivated or doesn't do his or her job correctly, then most probably the functional requirements will be invalid. So the issue here is that the solution architect will be the one who is responsible for the system's failure. Even though the functional requirements are invalid, executives do not understand the difference between functionality and technology. It's often mixed for them. So it's a good idea to understand that there is a problem with the requirements themselves instead of um, thinking about that the technology is incorrect. So what happens here is that the analyst is being robbed from his personal power. So he is doing a bad job, he realizes it, but passes it to the solution architect anyway. And of course, there might be a conflict between the user representatives, the actual clients, and the functional analysts. So there's a problem with the functional analysts, and it's very difficult to understand why, but for some reason he passes invalid requirements. So the solution is we need to find why the functional analyst is not doing his job correctly. Why he always and not always but often fails his documentation. So most probably he is lacking his personal power. He doesn't feel confident about himself. He understands that his job is bad, but he doesn't think that he will improve. So we need to empower the guy. We need to restore its personal power. We need to encourage him. We need to help him shape shape the requirements. We need to help him understand his main mistakes. We need to help him improve at his job. And of course, if the functional analyst is a douchebag, well, we need to escalate up. So we need to talk to the CTO or the CEO depending on the company structure. So if we can't fix the issues coming from the functional analyst by talking to him or her, we should escalate the issue. There is nothing else to do here. The third error is if the planning is too optimistic. If the planning is too optimistic, we have a problem with the project manager. So he's responsible for this problem. Most of the time, he's unaware about it because um, he or she may plan the solution, he or she decides some deadlines after a discussion, of course, but still, the planning may be too optimistic. So what happens here is that the QA is being robbed of his personal power because the QA is constantly receiving messages or conversations like, well, we're in a hurry, there is no time for testing. Just pass it. Just pass it. We cannot test. Just pass everything. We don't care about testing now. And the QA is feeling that he is no longer able to recover from that because he is no longer able to do anything about the final product. Also, we have a lead developer who is being robbed of his personal power too, because we are going to tell him, man, there is no time for mentoring. There is no time for training or code review. Just keep pushing code. Just write features and features. So the lead developer doesn't feel like an actual leader. he doesn't feel like a mentor, he doesn't evolve his developers. These people just become code monkeys. They just do the grunt work and don't evolve. So the solution here is to bring the project manager in on the dev team. The project manager may not be aware how an actual software is developed. If the project manager is not a technical guy, he may not understand software engineering principles. So we should give him the knowledge. We should make him some presentations. We should describe how software development is created, how software development life cycles work, and we should explain to him what he should expect. And he shouldn't expect software to be written just like that, because there are a lot more processes involved in software development than actual coding. So the project manager should understand that and should plan that accordingly. So we should find the reason, because maybe the project manager is correct and maybe his planning is quite okay, because if he's a technical person, he may understand very well how software is built. So the reason may be optimistic project manager. Well, okay, but there may be a naive lead developer. If the lead developer thinks that an issue may happen in 2 weeks, but the actual time span is 4 weeks, then the lead developer is the problem. So we should understand why the lead developer doesn't understand planning, why the lead developer doesn't understand scheduling, what is missing, and so on. Of course, we may have slow or lazy developers. We may have too many junior developers, and maybe the lead developer is constantly trying to help them. So maybe the senior developers in the team are too busy helping the juniors. So we may have slow developers or we may have lazy developers. I had such situations with lazy developers, with slow developers, and that's part of understanding the problem and solving it. So here it's our job to coach the lead developer, to restructure developers, to hire new people, to alter planning. As you can see so far, it's most the most common solution to all group-related problems when we are a solution architect is because the company or the people in the company are not completely educated about software design, software solutions, software engineering, and so on. So it's the solution architect's responsibility to educate these people. It's the solution architect's responsibility to present to these people why something is not working and what kind of responsibilities different roles have. Good. Let's go to the final common issue, and that is when the architect role holds no power at all. So the project manager and the functional analyst may see the software architect as a producer of documentation. So nobody listens to him. Nobody understands his vision, his idea, his designs, and nobody is caring about his opinion. So the software architect just produces documentation of how the system is going to be built, but he doesn't have any power and doesn't have any decision making here. Nobody is listening to him. So the software architect currently is being robbed of his implicit power. He is a software architect, but he doesn't design any software. Or at least he doesn't decide anything related to the software architecture. So there is no communication involved and there is no leadership involved. So here the problem is that the organization itself doesn't understand what an architect should do, what are the responsibilities of the architect. And here the project will most probably fail. The same thing, we are in a hurry, no time for testing. We don't care about what is needed, because the solution architect may say we need to have testing, This is a very difficult architecture because we are having too many microservices, for example. So we need to assert, at least with a QA, with a manual QA, that the project is completed, that the project is working correctly. Uh, but in the perfect scenario, we need automated tests. And if nobody is listening to this guy, then sorry, but the project will most probably fail. What is the solution? Well, we should educate the C section. We should be the change maker. We should analyze why nobody is giving any power to the software architect's role, and we should communicate that. We should talk to people and educate them what is our part in the project. So we should team up with the project management, with the QA, with the functional analyst, and the lead developer. Once again, we should educate the people around it. So we should become the owner of the entire software process to make it more perfect, to make it more like the roles and the processes we talked about earlier. And of course, if the organization is unwilling to change, just leave it, even if that's your first software architect role, it may not be worth it to stay there because you will not learn anything. You will just produce documentation and documents, and you will not create any architectures. And there is no point in that. So architects should understand the business. That's very important. Every architect should understand the business very well. It should understand what are the business weaknesses, what are the business competitive advantages, what are the main strengths in the current business, because the architecture is commonly built around that. The architect should understand what is the competition. For example, the competition may have faster solutions than us. So in this situation, we should concentrate on performance. We may have some artificial intelligence involved, but the competition may have a better one. So we need to understand that, and we need to propose our designs accordingly. And of course, we need to understand the growth strategy of the business. We need to understand the budgets. We need to understand what is the plan for the company in the next year, whether we're going to grow in terms of development, how many clients are going to be in 1 year, 2 years, 3 years, because this growth strategy dictates whether we should consider making a more scalable solution, for example, if we have more clients. So every architect should understand the system goals and keep in mind that goals are not requirements. Goals are not requirements because goals are not what the system should do. Goals describe the effect on the organization itself. I have some examples in a minute, so bear with me. Usually, the goals are described by a client, and the architect should think about the big picture. He should think about the future, the current, present, and the future, and the architect should think about the company's clients, because usually the architect, the client of the architect, is the company itself, because we're building an architecture for the company, but we should understand the company's clients. So we should work for our clients, especially if we're a contractor. If we're working not a full-time job for a company, this company is our client, and we should understand the company's clients to know what are the goals of the system, and we should think about the big picture. So these are not requirements, and let's see different goals from different examples and different goals. For example, let's say that we have an HR system, human resources system. The organization is some product-oriented company. What is the goal here? So we are not talking about the requirements, that the system should have these kinds of pages and the administrator of the system should be able to do the following things. No, we're talking about what is the main goal here. The main goal is streamline the recruitment process. So we should care how to automate the manual work involved in the HR team. So we should know that the goal is to make their life easier. And if they propose some features, we should analyze the features and we should even be part of proposing better designs for these features. Okay, the second example is about reporting and mapping criminal incidents. What is the organization? Here it's a large city. So what are the goals of the system? So the goals should improve police response time. So we should think about the system to be real time, to be uh, to be as fast as possible, and it should be able to deliver reports to the police as soon as possible. Also, with improved criminal incidents in terms of, for example, reducing the criminal incidents, we can attract new residents. And here we may have a hidden goal to help the mayor win their next elections, for example. So the goals here is to improve police response time and attract new residents. These are the main goals. Finally, we may have a mobile flash sales system. We have a small startup which wants to increase their revenue. So the goals here are to generate quick revenue stream. So this system should be developed as fast as possible because the startup requires a new revenue stream. So we shouldn't give them a complicated solution because this is not the goal here. The goal is to be as quick as possible. And another goal is to attract investors. So the small startup may need investors as soon as possible. So we should consider these goals. So goals are different from requirements, and that's important, and we should consider them. We should understand the business and the goals of the business. Next thing is that architects should watch their language. I'm going to give a lot of examples here because usually architects are technical guys. But talking to non-technical people, uh, it requires a little bit of skill because these people don't care about what you care. So you need to understand uh, how to deliver your information, how to talk with these people, and so on. For example, project managers. These people care about project success and budgets. They care about planning, they care about time frames, they care about cost efficiency, they care about the success of the project. So avoid technical mumbo jumbo and things like, hey, this is the latest and greatest pattern. We will be the first to test it out. It will be super cool. We can write a blog post about it. The project manager doesn't care about latest technologies, patterns. They don't care about whether we're going to be the first ones to test that out. Developers, on the other hand, care about these things. So we should present such sentences, such information to developers, but the project manager, he will not be impressed. So we should use something like, this new technology can help us write the code twice as fast. Twice as fast. So we're talking about budgets and planning here. So we can cut our schedule and budget accordingly. So to get the approval of the project manager, we should talk about budgets. How our design is going to improve the budget, the costs, the time frames, and so on. With the lead developer, it's quite the opposite. These guys care about code and technology. You can impress them with that. So we can use, they don't care about planning that much. They don't care about budgets, costs. They care about the code. They care about cool new shiny technologies. So we can say something like, hey man, have you heard about the latest React version? We're going to use it because it's super cool. It includes some new cool features, for example, React hooks, even though hooks are currently not that new, but that kind of a talk is required when we talk with the lead developer. And we should watch our language, of course, with the C-level guys, with the CEO and the CTOs, because these guys care about financial bottom lines. We should avoid any technical buzzwords, mumbo jumbo, they don't care about that. We should use something along the lines: the architecture I've designed will ensure the continuity of the business and will be able to cope with the high loads expected during Black Friday sales. So what's the important part here? We are designing an architecture which will help us with the Black Friday sales, which will help us with the high loads in such scenarios, which will help us with the continuity of the business. So these guys care about the business stability and the business revenue streams. So we shouldn't mention anything related to microservices or something like that. Of course, some C-level guys understand some technical concepts. For example, a lot of guys understand what microservices are, what a monolithic app is and what a microservice app is. Most of the C-level guys, which are in tech companies, of course, understand that, and these guys knows the pros and cons. So sometimes you need to help them decide by using words like this. Of course, you are not lying to them, you're just presenting the information in a way that's more understandable to these guys, to these rows. Good, let me check the questions. Everything is fine. So let's continue and let's now talk about the soft skills which are required. The first one is listening. We should be a very good listener. This sounds very easy, but actually it's not. We should also consider the person, we should always consider the person we are talking to. And uh, something that is super important when we talk to developers or the team leaders or so on is that we should never think that we know everything about technology. Like I said, uh, after 8 constant years of learning, I'm still learning new stuff and I'm still improving. So I'm sure I don't know everything about technology. And like I said, I learned new tricks from this live class, from this class itself. So we should never assume that we are the smartest person in the room, and we should always listen to other people and what they talk about. We should forget about our ego. Most of the time, collective wisdom is way better than individual one, because consider that if the developers are rock stars and if the lead developer mm, is an A team member. He is an excellent guy, an excellent employee. So why shouldn't we listen to these guys? They're all great. We should listen to them. We should discuss everything with them, and we should understand that they may have solid points. The second soft skill is we need to deal with criticism, and we need to deal with criticism a lot because our work is going to be criticized. Because we as software architects don't have any implicit power. We don't have, we're not in charge of anything. We are not the boss of the lead developer. We are not a manager of anyone. We just work with the other guys. But we are not the manager of the team leader, of the lead developer. We are not the manager of the developers. We are not the manager of the project manager. We are not a manager uh, to pretty much anyone. Of course, if we have mixed roles, we may be a manager, but if we are the pure software architect doesn't have a management role. So if that's the case, we're going to be criticized. Everybody's going to ask questions, and some people may not agree with our opinion, and that's completely fine. So we're going to be asked a lot to explain any logic behind our decisions. Because if, for example, our architecture is quite expensive, the CEO is going to ask us why we are doing such architecture. We need to defend ourselves. If we're using some very difficult or unfamiliar technology, and the developers are asking why instead of using their main technology, we need to explain that too. We need to answer these questions. So the deal here is to do not attack back, because attacking back, it will put us in a very bad position, and attacking back is not doing us any favor, because like I said, we are not the manager of these people and we are not in charge. So attacking back may lead to something not that great. We may encounter the problem with the lead developer losing trust, and so on and so on. So never attack back, always discuss. Because when somebody is criticizing us and asking a question about our design, we may have two main reasons. First, we may have a genuine question. So somebody may be curious why we decided to do our architecture this way. Or maybe somebody is missing some knowledge and needs more information to understand our design. So these may be genuine questions, because uh, if we have genuine questions, we just need to provide facts and logic. It's completely okay to say, good question, let me think about it, let me answer you later, let me calculate some things. I'm going to answer you in 2-3 days because I need to consider your question. That's something I've thought about, but I never thought in detail. It's completely okay to postpone the answer, but it's completely wrong to attack back. It's completely wrong to say something, this question is invalid, your point is invalid. That's not a good idea. And most of these advices may sound like common sense, but in different situations, people react differently. Sometimes we may not understand what's the best answer to the situation, even when we don't know that maybe the people is just asking simple question. So it's a good idea to always be as politically correct as possible. And if you are not familiar or if you don't have the knowledge to answer the question, postpone it in a fashionable manner. Just say, that's a great question. Let me think about it for 2-3 hours and I'm going to answer you, something like that. Of course, they may be the reason of mocking. So somebody may be mocking you. Think about the why here. Why somebody should is mocking you. For example, if the lead developer is mocking you, he may want your position. So this is why he may try to make you look bad in front of your colleagues. So think about the why. Because most of the time it's probably their fault and not yours. You may done a perfect job, and even though even considering the fact that you did a great job, somebody may still mock you for a number of reasons. So never get offended and never attack back. Just say again, good question, let me think about it, let's consider that, let's discuss it. Never get offended. So you should be smart and not right. You shouldn't be right. Like I said, you are not the manager of these people. You cannot make them formally do anything. So if you're not in charge of them, you should be completely smart how you play your cards, because you may be the one who will take the damage if you don't do it. So be smart, not right. And let's consider the following example. So you're presenting your architecture in front of the CTO and some senior experts. So the CTO needs to approve your design. Of course, somebody questions your design in a very common professional manner. I believe the stateless pattern is useless here. It will hinder the performance. Someone from the senior experts states that. Someone decides to question the design and think that you are wrong. So you know that you are right. You know that the senior expert is actually wrong, but you should not attack back here. Your goal here is to get an approval of the architecture. Your goal is to uh, make the CTO like you or make the CTO like the design. And if you get angry or if you get offended, if you attack back, the CTO may think that you're not trustworthy because you're going to show weakness, you're going to show bad emotional intelligence. So what you should do is don't do the things to make you feel right. Don't say you're wrong, the system is under heavy load, the stateless pattern will help us with that. Don't do that. Don't attack back. Don't be overly defensive. Just answer smartly to get everyone's approval. You should always say something like, well, that's a very great point, but we actually had a lot of thinking about it. We thought about the stateless pattern for hours. So we believe that it's the better option. But I'm completely okay to have a further meeting so that we can discuss it in more detail. So first, this way you're going to get a lot more respect from everyone because first of all, you agree with them. When you agree with somebody, he instantly likes you. Second of all, you avoid a long and boring technical argument because if the senior expert wants to prove his point, he will start arguing, and that may be very long, very boring, and the CTO may start not liking you because you are wasting his time. And finally, most probably you avoid the meeting afterwards. If these guys are super busy, and most of the times they are, for example, the CTO should be super busy, the senior experts hate meetings most of the time, so you may avoid it, the further discussion. Especially if you agreed with the guy and if you said something that you had a lot of thinking, it will make him feel bad at the end of the day. If he is wrong, he will be feeling very, he will not be feeling okay because he wasted a lot of your time. And if you say that you had a lot of thinking, he may realize that he may not be actually correct. So most probably you've avoided this meeting too. What other soft skills are required? Well, such a role requires organizational politics. You cannot avoid such things. So, unfortunately, all the technical guys want patterns, want writing code, want designing the solution, but with such a role, we should cope with the politics. For example, let's consider the following fact. The CTO of the project doesn't want to do microservices. It's new, it's untested, it's very immature pattern, and it's too risky. I don't like it. That's the CTO's opinion. So even though you provide a lot of case studies, the CTO refuses to accept your solution. And you know that microservices will solve a lot of the system's problems. And instead of searching for other technical solutions that may solve the system's problems, you may try to understand the situation here. There may be some other reason for the CTO to don't like microservices. And for example, it may turn out that the CTO is going to be replaced soon and he's just rejecting everything because he's angry. And that's a typical scenario when you deal with people. Because if the people has some personal problem, with the company, he may refuse something or he may not be cooperative because of that. So don't think about the technical aspect of your solution, but think about the politics. For example, if you receive a huge no about your design, think about the politics too. There may be something that is hindering your process, your designs, your solutions, and so on. So, for this example, if the CTO is going to be replaced soon, what we should do, we should just prepare the future CTO and discuss the patterns with him. This way, we may see that actually the microservices are going to be implemented soon. So, what is the lesson here? The lesson is that we should be aware of organizational politics, but we should never be part of them, because such politics may give us short-term leverage, but in the long term they will hurt, and they will hurt you very badly. I know such situation. I had such scenario. We had a guy who grew very fast in the career ladder. He advanced his career quite quite swiftly. For maybe for a year and a half, he became a director. He became a management role, and he did that with politics. He managed to position himself such that he always find a leverage, and he always find the way to sneak a bit, and he always found the way to advance his career. Of course, he worked hard, he worked a lot, and everybody saw that, but he also was part of organizational politics. He talked bad behind people, he always created some drama here and there, and he was very good at that. So he gained a lot of short-term leverage, but after 1 year and a half and maybe a little bit less, I'm not quite sure about the time frame, but he was fired, and the company understood that he was doing some drama. He was creating a lot of issues for the other managers. So the company fired him. So in the short term, he advanced his career super fast, but for the long term, it hurt him badly. So be aware of organizational politics, listen what is happening, think about the politics, but never be part of them. Never create extra drama. It's not worth it. Next, what we need as soft skills? Well, we need public speaking. Architects have no formal authority. Like I said, they're not in charge of anyone. So public speaking is a must. Architects don't have any final decision, so they need to use words to uh, make everyone agree with their designs. We need to be sure that people will agree with us. So we should influence by speaking skills. And I'm not talking about be the perfect presenter. I'm not talking about be a world class presenter. No, you just need to talk in front of 10 people, 15 people, 5 people. You will be part of many meetings and you should be able to defend your solutions, you should be able to defend your opinion, and you should be respectful. So you can learn public speaking, even if you are not a good public speaker, even if you are shy, if you are quiet, even if you have difficulties talking in front of people, that doesn't matter. You can learn that. I learned to talk in front of people. I was never a good public speaker. I am a super shy person. I am an introvert. So it was very hard for me. But these things can be learned. So You should be able to stand in front of an audience and present your solution and even defend it. You should influence with your words. So the main concepts here are defining a clear goal of your speaking. You should know your audience. You should know how to speak, like the examples I showed you earlier. So you should know how to speak in front of these people. You should be very confident, or you should pretend to be confident. It's very difficult to be confident about your first solutions if this is your first job, if the whole responsibility is on your shoulders. It's very difficult to be confident. I understand that. It's very difficult to be completely confident about your solutions. It's completely normal to have self-doubt about your designs, so that's part of the job. But pretend to be confident. Don't be soft. Be politically correct. If somebody asks you questions, don't attack back, but don't be soft. So pretend to be confident because that's important. People will listen to you and will agree with your designs when you're feeling confident. Also, don't read the content from the slides. Always talk about lots of things. For example, my slides always include a lot more information than necessary if this was a presentational lecture, if this was something that I needed to convince someone. If I needed to convince you about something, I will write uh, I will write a lot less content on the slides because people know how to read, and if you read the content from the slides and the slides only, it will mean that you are not confident about your solution, and it will mean that you are not quite sure whether you are correct, so you over prepare the slides. So don't do that. Of course, I'm putting a lot of texts in my slides because I want all my presentations to be as readable as possible, because uh, sometimes students don't learn everything from the lecture because lectures are long, videos are long. So sometimes a person may decide to just read the presentation to get the summary of the video, to remember something. So it's a good idea to have more text in the presentation for this scenario. But if you're trying to convince something, just put bullet points and nothing more. Finally, maintain eye contact. Don't maintain eye contact with a single person. Do it with everyone in the room. Just do a round robin around them. You can practice that. These are the main concepts of public speaking, but I cannot teach you public speaking in 5 minutes. That's impossible. If you're if you're not a natural public speaker, just take a course. There are a lot of great courses on public speaking, and because it's very important skill for any job out there, it's super important to defend your thoughts, to talk in front of people, to present your ideas. So just take a course on public speaking. You will learn a lot and you will improve. And public speaking improves with practice, trust me. Trust me, because currently I can speak publicly in front of 200 people without any issue, but I'm the type of guy which is very shy to ask somebody on the streets what is the current time. So these things can be learned. Don't uh, don't stop yourself. Don't overthink about your lack of skills. Don't overthink. Don't think that it's set in stone. Because some people say something like, well, I'm too shy, I will never be able to talk in front of people. And they stop themselves this way. Don't do that. Of course, if you are a shy person, it will be more difficult to learn how to speak in front of people, but you will eventually do it if you keep practicing it. You eventually learn it. You may not be the perfect world class uh, speaker, but you will be good enough to do your job flawlessly. So these things can be learned. Of course, a soft skill about software architects is that we should constantly learn. You know that the development world changes in a blink of an eye, so we should always keep learning. A lot of frameworks and patterns get completely forgotten in months. For example, 5 years ago, Angular was just getting started, and currently people are using it quite a lot. People are using React. 5 years ago, nobody talked about React. So a lot of these frameworks get completely forgotten. If not for months, then for years. For example, jQuery or Grunt. If you are a new kid in the tech world, you may have never used it. And 3 or 4 years ago, jQuery or Grunt were the bomb. So, yeah, everything is constantly changing in this world. So we should keep adapting. It's a very difficult thing when we have a very difficult job like software architect. Uh, the software architect role requires a lot of concentration, a lot of time, but we need to try our best to improve our technical knowledge. So Angular is also dying right now. For example, 2 3 years it was the best framework out there, but React, Vue, even the new kids Svelte are currently considered as better alternatives to Angular, and a lot of front-end developers think this way. So mm, Angular may die in 1 or 2 years. Also, something else that is super important is that the core team of Angular is getting less and less developers. A lot of core developers are leaving it. So, with that said in mind, most probably Angular is going to die at some point, and it is going to die before React. So, these frameworks are most probably going to be replaced sooner or later. So we as architects should understand these frameworks. Of course, we don't need to know the details. We don't need to know how to use them and how to write code with them. But we should know the main differences and what are the competitive advantages of one framework compared to another. So we should understand what is React, what kind of problem it solves, what are the pros of using React, what are the cons of using React, this kind of things. And this kind of knowledge is easily learned, so we don't have any excuse. Well, of course, like I said, we don't have to know the tools in detail, that's the developer's job, but we should know when and why to use the tool. Main sources here are blogs, books, webinars, and a good idea is to read the table of contents of online conferences, for example, even offline conferences, it doesn't matter. Read the table of contents, read the topics. It's not necessary to watch every conference out there, but read the buzzwords. Usually, on conferences, people are talking about the latest things. They're talking about the cutting edge, the bleeding edge. They're talking about the latest version of the tech. So, reading the topics will give you a good idea what are the next things that are going to emerge in the tech world. Just reading the topics. Of course, if something is interesting, watch the whole lecture. That's completely fine. But reading the topics will give you understanding of the buzzwords of what you need to understand well. And for example, if you see Kubernetes quite a lot, if you see it on a lot of topics, then this means that it's time for you to understand what is Kubernetes, what kind of problems it solves, what are the pros of using Kubernetes, and what are the cons. So keep an eye on blog posts, books, webinars, and read the topics. Read the topics. Don't watch them. Watch them only if you find them interesting, but read them. It will save you a lot of time understanding what is the latest tech. Good. So let's make a small 5 to 10 minute break. Let's do 5 minutes and we're going to continue. We have 5 slides and we're going to start talking about the technical things. But of course, with such a role like the software architect, it's very important to understand the team, to understand the people in the software development process, to understand what are the responsibilities, what are the soft skills required. So these were super important. So we needed to cover them. 2-3 hours talking about soft skills, I know for the tech junkies it's a lot, and you may want to know more about the architecture itself, more about the technologies, more about the different types of patterns and so on. But these skills, the soft skills, the understanding of the organizational charts, the understanding of the roles, these are part of the job, and it will be irresponsible of me if I create a lecture about software architects and not mention these things, because these are 30% of the work, and that's quite a lot. Okay, so let's take a 5 minute break and we're going to continue. When the timer reaches 5, I'm going to return. Accidentally, the break became 10 minutes, but nevertheless, we should now continue. Let me check how are the questions. Everything is fine. As usual, most people prefer to watch the recording and ask questions with the messages system, but nevertheless, suit yourself. So, first thing you can do about assessing your soft skills is you can find your personality traits. There's a very good test for that, which is called 16 personalities. I'm not the type of people who is all that into tests. I'm not that interested in, for example, zodiacs, tests, all these kinds of things. But this test is quite good, actually. If you're not familiar with the 16 personalities test, just do it. So it will give you a lot of interesting things, to give you very fun results, and for me they were quite accurate. The problem with the architects is that architects require somewhat incompatible personality traits, because you need to have very strong intuition, insight and vision, which introverts or analytical personalities are quite strong in that area. But also you need to have super strong communication and leadership skill, which part of the extrovert or the feeling personalities. So these are quite opposite, and it's very difficult to have them naturally, but you can work on them. So you should find your weaknesses in the four architect skills: insight, leadership, vision, and communication. We talked all about them. Let me talk about my assessment here. So my test resulted in assertive commander. People which are assertive commanders, based on 16 personalities, are people like Steve Jobs, Gordon Ramsay, Jim Carrey, Doctor Strange from the comic books, and others. So I'm a person who loves good challenges, achievements. I love something that is difficult for me. I love something that evolves me, something that advances me, something that will make me more knowledgeable. So my perfect career path is like the video game achievement system. I have various achievements and I'm trying to unlock them all. The more challenging is an achievement, the more I want it. So this is super correct for me. This is why I started various startups. I started a lot of projects because they were challenging for me, and this is why I'm super eager to do difficult things. Also, I have a very ruthless level of rationality, so I'm super rational. Everything is 2 plus 2 equals 4 around me. Everything is mathematical and everything is about logic. So the emotional part of being a human being is very low around me. I'm not super emotional, and I believe I don't understand emotional emotions that well. So with my rationality and my logic, I overwhelm the more sensitive people. All people which are more sensitive, more emotional, it's super difficult for me to communicate with them. So what are my strengths? My strengths are that I'm efficient, I'm energetic, I'm self-confident, strategic, and inspiring. And I believe these are true. In terms of efficiency, I do a lot more things in a typical day than the average person. Of course, I'm not super efficient with my deadlines because mm, The problem here is that sometimes I promise something and I cannot deliver it on time. I always deliver it, but sometimes I delay it a bit. And it's because I don't consider uh, various things that may happen, various disasters that may happen, exceptional things that may happen. So, in terms of producing a lot of work and uh, giving a lot of results, I'm super efficient. I deliver more than the average person. I'm super energetic because if I wasn't energetic, I won't be efficient. That's kind of logical. I'm super self-confident because when I set myself some challenge and I achieve it, that boosts my confidence. And if my whole life is based around achievements, most of the time I reach them one way or another. I find a way to unlock the achievement. So this boosts my confidence. So I'm self-confident. I'm strategic. Like I said, I think about a lot of things. I think about the logical part of things. So I'm super strategic. And finally, I try to inspire people. And I believe it's happening because a lot of people follow me. A lot of people try to understand how I became such a good software developer, what I did. A lot of people like my content, a lot of people like my lessons, so I believe I'm inspiring for a lot of people. These are my strengths. My weaknesses are that I'm stubborn, I'm impatient, I'm intolerant, I'm arrogant, and I'm emotionless. And this is all true. And I tried to work on these weaknesses, and I believe I'm mm, I haven't fixed them, but I have a lot of improvement because with these strengths and these weaknesses, the problem is that I cannot work with people that well because I'm impatient. Because if I'm super efficient and people around me are more average, which is not bad, but not it's not my level of efficiency, I'm super impatient and I'm intolerant that they're slow. And that's not a good thing because, like I said, to to advance your career, you need to work with people. You need to understand people. You need to be better with people. So if I am intolerant and impatient, if I'm arrogant, I will have a lot of problems with people. And I had. And I saw that I had these weaknesses and tried my best to improve them. And currently, after 3 years on a people management position, I believe I improved a lot. So even if you have a lot of weaknesses that you think that you are part of your character, keep in mind that all of these can be improved. If you are mindful about them, if you understand that you are arrogant, you will try to improve your language towards more emotional people because you know they're going to be offended. They will get offended, and that's not giving you any favor. So the thing is to understand your weaknesses and work on them actively, and they will improve. I promise you that. I improved a lot for the last 10 years. I had a lot of problems in terms of stubbornness, impatientness. I was super intolerant, but currently most of these things are things in the past, or at least uh, in most scenarios. So the perfect career path for me is executive positions or entrepreneurship. So that's a given because if we consider where you watch this video, that's my own entrepreneurship, so to speak. So it's something that nobody told me to do it. I decided to do it. I decided that I want to produce this content. I want to produce this video. I want to produce this lesson, and so on. So it's on my own terms. So my career path should have a lot of responsibility, growth, opportunity. This is how I became a CTO, super fast, 6 years. But yeah, it's fast, but it's not without hard work and constantly seeking growth. It's not because I didn't put in the work. I put a lot of work. I wanted to make a great name. I wanted to create a lot of I wanted to have a lot of experience. I constantly worked. I did a lot of projects. I improved on a daily basis, and I wanted more and more responsibility. And most importantly, I catched opportunities when they presented themselves. So this is how I had a, so to speak, very fast growth in my career because I craved that and I worked my ass off to do it. So here I can remember the backstory about the interview. The interview from the previous one of the previous videos. The interview was about software architectures, and I was the client. They didn't approve me as a software architect, and I was super motivated to actually do that, to actually improve myself. So I had huge personal power there. I stand up on my feet and I'd say in 1 year I'm going to be a great software architect. And I learned a lot and improved a lot. So something else you can do for your assessment is the communication. Which are the bad communication habits? The bad communication habits are criticism. Do not criticize without any valid arguments and background knowledge. I was super critical of people, but I improved that. I was super critical. I was constantly thinking that people uh, are no better than me, for example, and that's not a good card to play. It's not the best thing to think because when you think that you're better than anyone else, you improve a lot less because you underestimate what these people are going to tell you. So don't criticize. Don't criticize, don't tell people uh, bad things without any background knowledge. Most of the time, most of the times people will tell you something based on their knowledge and background experience. Try to understand why are they telling you this. Sometimes they may tell you something that's not appropriate, but still consider their background knowledge. There is some reason for their words. So don't criticize them. The second bad communication habit is contempt. When you underestimate people and their abilities, and I did that too, because I always thought, like I said, that I'm better than anyone else, which is the biggest lie I can tell myself. This is absurd. So we should never underestimate people and their abilities. We should always consider that these people can teach us something, even if you're the software architect and you're talking with a junior developer, they may have read something that you didn't, and they may know something that you didn't. So don't underestimate them. You may still learn a lot from people all around you, no matter whether they're 3 levels beneath you in terms of their career. It doesn't matter. You can still learn a lot. And if you don't underestimate these people, you may learn something mm, which is not that important in your job, but it's important in your personal life. So this is contempt. Never do it. Try to improve it. Because all of us do these bad communication habits, but we should always try to improve them. That's the important part here. Next is defensiveness. So we shouldn't attach ourselves to our own solutions, designs, our own thinking. And this is super important because a lot of people do it. A lot of people think they are always correct. So never be defensive, never be overly defensive. Be respectful, think about why the other person is asking you a question or is mocking you or is telling you something. There should be some reason about that. Don't be overly defensive before thinking about the situation. And finally, stonewalling. Being stubborn about everything you don't believe in. For example, if you believe in something, no matter whether it's personal or whether it's about uh, technology stacks, for example, never be stubborn about everything. You may super hardly believe in something. Keep in mind that it may be a bad idea to not consider other people's opinions. So never do stonewalling too. So the whole idea of being a software architect is that you want to inspire and motivate the people around you. You should constantly do that in your job. If you are a software architect who wants to thrive in their workplace, you need to inspire and motivate people. People should have huge respect for you. So all of these happen with healthy, powerful, and uplifting communication. uh, think about your mistakes, think about them, improve yourself, apologize, be politically correct with people, use the right words with the different people, uh, see the strengths and the weaknesses of the people and act accordingly. If somebody is super emotional, don't use strong words because uh, they will catch on these words. They may get offended. So it's very important to have healthy, powerful, and uplifting communications. I will upload and I will provide a document with some questions. You may try to answer these questions. Think how you can improve yourself by answering these questions. And these questions don't have a correct answer. They're just here to help you understand your personality. So make sure you assess yourself. Also, you should assess yourself as a leader because leadership is a very tricky business. You need social political power, how you present yourself unconsciously. This is, unfortunately, it's part of, how to say it, it's not the best thing in the world, but it happens and it's there and it stays. People think about that. I'm talking about what is the first impression of other people about you. Because, for example, if you are very tall and very handsome person in general, people will love you more, and that's a given. I don't like that. I don't like that. I don't endorse that. And, mm, but unfortunately, it's there. And this is how you present yourself unconsciously. So you should try to improve every part you can do around that. So if you believe that you don't look that well currently because you are out of shape, for example, or something like that, mm, it's a very easy way to bring yourself in shape because this will give you 2% advantage when you talk and try to convince people. I know it's silly. I know it's how to say it. It has a lot of discrimination around that. I know that, but this is how the world works. Unfortunately, this is how the world works. Uh, and social political power is something you can improve if you find your weaknesses and decide to work on them. Of course, you cannot improve everything. If you're, for example, not that tall. You cannot improve that, of course, but you can improve your first impression. You can improve your appearance. For example, you can change your haircut. You can, well, let's say it like this. I wear glasses and I have a huge lenses. I don't see anything without glasses. It's a big problem. It's a big medical problem. Of course, with glasses or contact lenses, I'm completely fine. With glasses, I look like the complete nerd, which is kind of cool, and I like myself with glasses. But if I need to meet more powerful people, I need to meet CEOs, CTOs, if I need to meet somebody who I consider uh, who I consider a lot more with a lot more authority than me, then I will go with contact lenses because without glasses I look more manly. I don't look that nerdy, the technical nerd, you know. And if I meet with technical people, if I meet with people with which I'm going to talk about coding and so on, then I wear my glasses and I don't care about them. This is the kind of social political power I'm talking about. What you can improve about your first impression is super important. Of course, you cannot improve anything. And of course, I know that these things are not fair because there are always more powerful people than anybody. There is always a richer person, there is a more powerful person, there is a more handsome person, and you cannot be the best in these things. But you can improve what can be improved actually. So you can think about these things. You can think about what you wear, what kind of clothes you're putting on. Mm, These things matter. Also, if you are out of shape and want to present yourself in your first software architecture job, even even improving uh, your body by going to the gym, for example, twice a week, uh, is going to give you a bonus because your posture will present authority because you have taller, wider posture, and people will have more respect for you, and that's unconscious thing. So these things matter. Uh, so you need to improve what you can improve here. I know it's not fair, but this is how the world works and you should use it as your advantage. Then you need positional power. What is the current position in a group or organization, paid or unpaid? There are people that are natural alphas, so to speak. They enter a room and everybody starts listening to them, and that's completely fine. So you need to be a good leader, you need such power. You need informal power, the power which other people give you by default. How you can improve that? You can improve that by uh, constantly improving and constantly sharing knowledge, because by sharing your knowledge, people will understand that you are actually a very resourceful person. So they can start giving you that informal power naturally. Of course, you have some things like historical power. This is how you grew up, what was your childhood, what were your teen years, because if you had a troublesome childhood, you may have some issues with your personality based on that. So you need to understand this and work on them. You may have personal power, but this is happening by making friends, coping with challenges, bouncing back from setbacks, and so on. I will give you, there will be yet another document which is going to be provided for you, which will give you even more questions and you can think how you can improve yourself. So let's think about my assessment, and I believe we're done with the everything about the soft skills. So my assessment, well, throughout the years I've dealt with all of it. Like I said, criticism, contempt, defensiveness, stonewalling. My personality, let's put it like this. When I think about, when I think that everybody else is not that smart, I'm going to criticize them a lot. I'm going to have a contempt. I'm going to be very defensive, and I'm going to be stonewalling. And these things are bad. So it took me quite a lot of work to understand that I'm completely wrong, and that mm, a lot of people may not be that intelligent in terms of logic, in terms of pure logic, the thing that I'm good in it. But many people are very good at a lot of other stuff that I'm very bad at. So when I understood that, my life and my communication with people became better. And when I understood that I'm not always right, and that I should always put myself in the other person's shoes, then uh, my communications skyrocketed ever since that point. So I had all of these things and I worked hard to improve them. And these can be improved. These can be improved. The thing is that you need to be mindful about these things. You need to analyze them. You need to watch about them and analyze them. You need to analyze your behavior and you need to understand when you were not correct. So thinking about these things during various situations is the thing to improve that. So I worked very hard for my power because I was literally nobody. I came from a small town. I didn't have any connections. I was completely not the cool kid at all. So I worked hard for everything I currently have, and I believe I achieved a lot by improving my power. And I'm going to give you some examples, and I believe we're done. So, social political power. So, I was never the cool guy. I was super shy. I didn't have any friends in my first 7 years, 7 school years. So from first to seventh grade, I didn't have any friends. I was talking with some people, but I was a huge introvert. I was super shy. I was super quiet, and I was not the cool guy at all. So how did I improve that? Because that's hard thing to improve, but I started doing cooler things that I like. So I started doing cool stuff. Cool stuff that I think are cool, but are generally perceived as cool. For example, in my high school years, I learned how to do beatboxing, and I became very good at beatboxing. And I started doing concerts about with my beatboxing skills. And all of a sudden, a lot of people liked what I do because I was interesting. Back in the day, beatboxing was not that popular. And a lot of people found that very interesting. A lot of people thought that I'm the cool guy. A lot of people wanted to meet me. They wanted to shake hands with me and say, "Hey man, I really liked your performance. You were great," and so on. And for a very introvert for a very for a huge introvert like me, that was super stressful. Doing a performance in front of an audience was super stressful, but I faced my fears. So I worked hard. It was very hard work, first to learn beatboxing, and second to face the fear of going in front of 800 people doing something that is considered very strange. Beatboxing was very strange 15 years ago. So that was something I did to be cool in high school. Then Later, I started learning. I wanted to improve my posture. The thing I said about being out of shape. I wanted to become, to have better posture, to look more confident by improving my looks, my body. So instead of doing the usual fitness, the usual gym stuff, because that's cool, that's nice, it's completely okay, of course, if you like it, but I decided to do something way more cooler. I decided to learn backflips, front flips, I decided to learn handstanding, and if you follow me on my Instagram, you will see that I do a lot of cool tricks in terms of gymnastics. I'm not a pro, of course, but I can do a handstand push-up, for example. So these things are considered cool by anyone's standards. Of course, not anyone is going to be super impressed because some people don't care about physical achievements. But still, when somebody sees that, they will say, "Wow, nice. That's respectful. You did a lot of work. You did a great job. You learned something difficult." So I started doing cooler things. I purchased a cool car. That's also part of having bigger power because people notice these things. People noticed material things, and I don't want to dress myself in costumes to look better because for some reason I hate costumes. Uh, my typical dress code is a t-shirt, usually with some stupid thing on it, something funny, something stupid, or something nerdy, for example, from the StarCraft game, because I'm a huge fan. So I'm usually wearing t-shirts, and that's not very respectful in terms of how you look. But when you wear t-shirt and when you have a cool car, people don't care whether you are in a costume or not. And because I'm a car guy, I decided to invest in a car to have a better power in terms of social political power. And it sounds silly, but people notice these things. People notice how you dress, what kind of car you drive, and so on, and they respect you for that. I'm not, I don't like that idea. I don't like that people respect you for material owning. I don't endorse that. I don't like that. I prefer people to respect me for my knowledge, for my hard work. But nevertheless, these things help improving your posture, buying stuff that are cool. For example, a more expensive watch if you like watches. If you like dressing up, buy a good costume, buy a good shirt, uh, buy a good phone. It doesn't matter. People look at these things and people see them. So I started doing cool things that I like. I liked cars. I like cars. I'm a huge car fan. So I purchased a cool car. That improved my power a bit. Then I started doing hard to do physical stuff, handstands, flips, and so on. This also gets some respect. Of course, if you're the complete douchebag and if you don't understand technical skills, nobody will care that you can do a handstand. But people see that you're confident about your skills, people see that you accept challenges, and people see that you are consistent on your challenges, so you achieve your goals. And back in the day, I learned how to do beatboxing. So these were things that I improved. And like I said, these things, these cool things, got me a lot more friends that I even imagined. So even if I was super bad at making friendships as a kid, that's not the case right now because I'm confident of these cool things. Next is the positional power. Mm, with all these personal stories, because usually I don't talk about my personal decisions, my personal life, and so on. I'm all about the business, all about the technical stuff, but I'm sure I can inspire somebody here. I'm sure that I can give you an example and I can inspire you to improve yourself, to think about what you can improve. And all of these small improvements will give you some benefits, I promise. in benefits in terms of your job, in terms of your salary, in terms of your opportunities, and so on. So, positional power. I always accepted challenges and learned on the fly. Again, the backstory, the interview I told you earlier, I always accepted the challenges. I always tried to improve myself. Even if I thought that I'm not completely ready for some job, I didn't care. I catched that. So it's very important to catch opportunities and accept challenges. Even if you fail, what will happen? Nothing. Even if I get a new job and I'm not ready for it, what will happen? I will find another job in the worst case, and in the best case, I will learn on the fly and become better at my job. So there is nothing that may happen. So accept responsibility, accept challenges, and take them. When I started as my first job as a CTO, not my only job as a CTO, I haven't been a CTO mm, more than once. But when I started the job, I was super unconfident that I would be a good fit for that job because I thought I lacked experience and I lacked experience in a lot of areas, but I worked hard and now now I believe I do great job and everyone are I believe are happy. The feedback about my work is excellent and believe me, I learned on the fly. So it doesn't matter. And what was the worst thing that can happen? Pretty much nothing. We may decide that I'm not a good fit for the job. I will apologize. I will say that I thought I was a good fit, but unfortunately, I need to learn more. I will apologize to the CEO, and everything will be back to normal. So nothing can happen from more responsibility. Informal power. Well, informal power is uh, I always try to help and mentor others, or at least point them in a direction. I always try to create lessons, to share my knowledge. I always try to share more than I have, so to speak. And that's important because this way, uh, by sharing content, people start to respect you and they start to think that you are a natural leader in terms of that knowledge. And that's true, especially if you try to share knowledge that is perfect. If you deliver more than expected, if you try to give as much as possible, people love that. People understand that you put hard work and people give you that informal power. Historical power, well, I was bullied as a kid, like I said, I was very shy, so this attracts some bullies, of course. It was not an extreme case, but yeah, there were some cases. I had a lot of anxiety, I was super shy, so these were very hard to recover. I was how to say, I was working hard to recover from this by becoming cooler, by start doing cooler things, because that's the important thing. By doing more cooler things, people are going to be more impressed with you and they will have more respect towards you. And personal power. So 3 years ago, I had a huge failure. We had a startup, and this startup failed loudly. I disappointed a lot of people. Not I, but we, as a startup, as a company, disappointed a lot of people, and I was super depressed. I thought that I won't be able to do anything that's on my own. I thought that I will have a lot of problems in the future because I disappointed so much people. I I was constantly negative about everything work related, and I thought that I will never be successful. And that's not a good idea to think about. These thoughts are very self-destructive. So after 6 years, maybe 1 year, thinking like this about myself, I started doing small things which improved my life, which made me feel how to say it, made me feel that I accomplished something. I started putting challenges, but small challenges, to make me feel better, to make me feel that I can overcome everything. Because I realized that I had a problem, an issue with my work habits, because I thought that I was a failure. So I started putting a lot of small challenges, and every time I succeeded them, and because they were quite easy, it was very it was easy to recover from such a depression, because I started thinking about how many successful challenges I managed to overcome. And when I thought about them, it made me feel better. And currently, mm, I'm thinking that I'm super successful in everything I do, even though I had huge failures, because I managed to overcome this depression, and I understood that all of my current successes are actually uh, the result of all these failures, because I learned what not to do. So I improved a lot. That's how I actually managed to create super advanced events. I learned a lot of advanced topics. I improved my tech skills. I improved my public skills. I improved a lot of things. I improved my communication. I improved my connections with the people. I improved a lot of things because I was a failure back in the day, because I failed a lot of things. I understood how not to do things to make them succeed. So I've worked very hard for my power, and this is more than a decade of hard work. So it takes some time, but small consistent effort produces huge results. Huge results. And time passes. Time passes no matter what, so it's better to improve a small step at a time, and in you will not understand how you will improve yourself a lot. Good. Enough with that. I hope it was inspiring. I hope it gave you enough information. I hope it gave you enough examples so that you can improve yourself. But still, enough soft skills and enough team roles and so on. So we reached the point to talk about software architecture. Uh, these are like 9 or 10 slides. I'm just thinking whether you should leave them for our next part. But let's start and let's see how it goes. What is software architecture? We are now going to cover the technical aspect, and we have a lot of things to consider when we are talking about software architectures. And first things first is to understand what is an architecture. So, architecture is a structured solution which addresses all common software attributes. All common software attributes, because sometimes we may have something very specific, but the common attributes should be covered. Our solution should meet all the requirements. We're going to talk about functional and non-functional requirements later, but we should meet all of them. We should have a performance optimized solution for the specific scenario. In some cases, 5 minutes, a 5-minute operation is good enough, but in some cases, a 0.05 seconds operation may not be enough. So it should be performance optimized for the specific scenario. We should have security shows in check, so no data leaks. Everything should be as secure as possible. It should be very manageable for developers. The solution will grow in the long run, and the developer should be able to manage that solution. The solution should be scalable for business growth. So, for example, if currently we have 400 customers, concurrent customers online, in 2 years we may have 4,000. And if we have 4,000, we need to have a prepared solution for that. Our solution should be able to cope with that requirement. And we should have a great user experience in terms of accessibility. It should be easy for the end users. So the major requirements are these three categories. First, we have user requirements. This is the way end users interact with the system. So these requirements come from the end users. End user says, well, it will be very great if we had this specific feature implemented. And we're going to say, okay, good, we're going to prioritize it and we're going to implement it. We have business requirements. Business requirements are usually to create the software as cheap as possible, as fast as possible. It should be better than the competitors, and so on and so on. And of course, we want to cut costs. We want to make the software as cheaper as possible. And finally, we have IT system requirements. These are the infrastructure requirements. Are we going to use the cloud? Yes or no? Are we going to have 32 gigabytes of memory, or do we need 128, for example? How many virtual machines do we need, and so on and so on. So what composes an architecture? The structural elements and interfaces composing the system. So we need to provide objects, the low-level building blocks of the system. But keep in mind that we don't have to provide super detailed system, because if we provide super detailed system as an architects, the lead developers may feel pressured that they don't have any choice in their design. So we need to provide the building blocks, but not the details. We're going to see enough examples about this in the future. We need to provide how these elements behave in collaboration, what communication is done in the architecture, how the different modules, the different elements communicate with each other. We need to separate each of the elements into subsystems. So we need to have composition of systems with subsystems, with their subsystems, and so on. So how these elements are mapped to trees or graphs, the high-level data structure of modules in the system, and the whole architectural style that guides this composition. This is quite theoretical, so this is quite it's the definition of what composes a great architecture. We're going to see so much examples, so don't worry about if you don't understand some of these definitions. So our design should cover functionality, usability, resilience, performance, economic and technology constraints, trade-offs, and aesthetic concerns. So functionality in terms of what kind of functional requirements we have, what kind of features. We should cover usability and what kinds, how easy it is to use the system, how to improve the usability of the system. We should cover how to make the system more resilient, how to recover from failures, how to make the system strong and cohesive, and so on. We should cover performance, we should understand what are the performance needs of the company, and then we should cover that in our design. we should consider what will be the costs. And depending on these factors, we should consider our technologies. We should make a lot of trade-offs, as you're going to see later, but a lot of trade-offs are going to make the perfect design for a given client. Our goal is to provide a document which will have all the high-level structures of the software. So we need to write a document about the high-level structure of the software. We shouldn't go into implementation details because that's the dev's work. The lead developer should work here. Of course, if the lead developer wants more implementation details, we may include that, but it depends on the person. Some people prefer to have more freedom to work with the architect, and some people prefer to have more strict requirements. So it depends on the person, but implementation details are usually the job, are part of the lead developer's job. We should minimize complexity so that the development should be as easy as possible. We should address all requirements, both functional and non-functional. And usually we have all the functional requirements from the clients, and they are easy to set up. We should ask some questions and we are done. But the non-functional requirements are our own job, because usually businesses won't give us these non-functional requirements. I'm going to talk about them in detail later. And finally, our architecture should be compatible with all use cases and scenarios for the business, and that's a given pretty much. What are the needs of our architecture? Well, these are the technical patterns we need. We need separation of concerns. Every separate model should have a single task and very cohesive task. We should have encapsulation, and each model should be very restrictive about its internal parts. So each module should expose only what is necessary and nothing more. We should have dependency inversion so that our components are very easily replaced. We should have explicit components so that we can easily see what kind of components our architecture is using. We should have single responsibility. That's pretty much self-explanatory. We shouldn't repeat ourselves. That's pretty much self-explanatory too. We shouldn't care about persistence and infrastructure. They should be detail. They should be a detail. We should care about the high-level things, and then we should consider the persistence and the storage, the infrastructure too. These are secondary. Of course, we need to consider them, but these are details. If we can ignore them, we should do that. But if the system requires something very specific in terms of a database, we should consider that. We should have a presentation ignorance too. We should separate the responsibilities of our project into separate bounded contexts. If you're not familiar with the term bounded context, you can find a lot of information online, but pretty much it's separating everything about our solution into different contexts which can work and which are related and which are very cohesive. So, for example, if we have sales context, in terms of the sales teams in our company, we have these entities, these different modules: opportunity, territory, customer, product, salesperson, and something pipeline, which is apparently something the sales team is working with. So we need these modules. And in terms of support context, the support team in our business, we have tickets, we have defects, product versions, and again we have a customer and a product. So these two modules are pretty much the same in terms of naming, but in terms of the sales context, the customer is a different entity, because the the sales context is interested in customers and they are going to be attracted to our product, how they are going to be marketed, how they are going to be, what kind of a customer, is it a high paying customer, is it a low paying customer, and so on. But the sales context doesn't care whether the customer has a problem with some product. So it doesn't care. But the support context cares about that. So the customer, in terms of the support context, is someone who already purchased something and has a problem, has an issue, has some support ticket. So the support context doesn't care about the customer, how the customer was acquired, whether the customer is from Japan or from United States of America, it doesn't matter. That's the important part. So the different contexts use different modules for their own purposes. These are bound contexts. You may find a lot of more examples online. And finally, our architecture should be testable. That's also super important. What are the abstraction layers and the abstraction parts of the system? Well, our system has multiple layers. Our architecture has multiple layers. We have the whole system. We have different modules or subsystems. Each module will have a layer. Each layer, for example, let's say that this is the HR system. The subsystem is about hiring. The layers may be presentational layer, how we present the hiring data, data layer, and so on. Then the presentational layer may have different components. For example, a component about visualizing a table with all the employees. A component visualizing a table, visualizing a form to add new employee, and so on. Then we have classes. These classes have data and methods. These are pretty much everything in our architecture. The solution architect works with this explicitly. So the solution architect designs the system, the modules, and the layers of the modules. The lead architect designs the classes, the data, and the methods in these classes. And the software architect and the lead developer, depending on the case and the scenario, are working on the components. So the components may be part of the software architect's responsibility, but may be part of the lead developer's responsibility. So it may be part of both roles' responsibility, and it's completely okay to be in both roles or in one of the roles. It doesn't matter. So the components are in the middle ground. Of course, in some cases, the solution architect may even help with classes, with the data, with the methods. That's also completely okay if the solution architect thinks that the lead developer needs that guidance, or if the lead developer requires that guidance. It's completely okay. Also, it's completely okay for the lead developer to try to design some of these parts. For example, the layers, the subsystems, and so on. It's completely okay to help the solution architect. After all, the solution architect's goal is to make the lead developer the next solution architect, to make him better. So these two roles should help each other. But in a typical scenario, this is for the software architect, and these are for the lead developer, and the components are for both. Good. So what is bad architecture? The bad architecture is a complex architecture, incoherent, brittle, untestable, unmaintainable, because all of these things increase the cost of the system, and increasing the cost of the system makes the business more difficult to operate and more difficult to invest more in the system. And good architecture is a simple architecture, a very understandable, flexible, testable, and maintainable. So all of these lead to a cheap architecture and a cheap system, which allows the business to invest more and more and improve the product. Of course, in a real world scenario, most of the time we cannot have all of these, but most probably it's a fixed thing. So our architecture will be mixed between some good qualities and some bad qualities. So for example, we may have untestable architecture, but it may be simple and understandable. This is what I mean by creating trade-offs. This is what I meant by specifying trade-offs. We're going to see in the examples later that usually you as an architect, you need to do some trade-off, uh, and you cannot deliver everything perfectly. That's part of the job, to understand what kind of trade-off to do. What are some design tips about software architectures? Well, first things first, we need to build to change instead of building to last, because our solution is going to be changed multiple times. The solutions evolve, businesses evolve, everything evolves, our way of thinking evolves. So we should create our solution around modularity and flexibility. We should be able to easily replace modules in our system because, like I said, we are going to change that multiple times. We should use different models, but we should analyze them and reduce risks. So these models should be more abstract. If we try to create various diagrams which are quite detailed, we are going to be taking the role of the developer. So we need to have a more high-level overview. It's a good idea to be close to the developers, to be involved in coding if you have the time as an architect, but still our models should be more high level. There should be uh, there shouldn't be any models that are super detailed. It's not necessary. You're going to waste your time and developers will feel pressured. So there is no point of making everything super detailed. We should use different visualizations to communicate and collaborate because our architecture is basically a very large diagram with text explaining that diagram. So we should have a lot of visualizations. And it's our job to identify, think, and research all the critical points of failure. So we should uh, put in a lot of work in research, in everything in advance. So everything we are not sure about, we should research it. Everything about security, scalability, resiliency, and so on. If we are not sure about something, for example, if we are not great security experts, we can hire an external contractor to help us with that. But we should think about security. If it's important for the if it's very important for the company, we should think about that and consider our options. What are the areas of software architectures? So our main goal is to minimize complexity. We should make the system as easy and cheap as possible. This can be accomplished by separating the designs into different areas of concerns. These are known as modules, or you may see them referred as components. But for the sake of simplicity, I'm going to say that different areas of our architecture are actually modules. So we can have different areas, for example, an area for the products, an area for the customers, an area for the support tickets, and so on and so on. We can have a cross-cutting area which helps all other areas. But we can separate all these things into different modules. Each module should have different responsibilities. This way, by separating our architecture into subsystems, it will be very easy to identify problems, issues, identify complex tasks, and make them simpler. The key principles of software architectures. So, separation of concerns. Each object and module should be its own concern and context. We should have the single responsibility principle. Every single element should have single purpose and should have a single reason to change. We should follow the principle of least knowledge. Components and modules should not know about the internals of other components, and this is super important no matter the layer. This is usually done through interfaces, and it's the simplest way to abstract things and make them publicly available. We should not repeat yourself, of course. We shouldn't have multiple components with the same purpose, and we should minimize upfront design. So we should try to design the minimum available architecture so that developers can do some work. Of course, we can polish everything and polish the next sections of the architecture later. So we should minimize the upfront design. We should be able to start working on the system as soon as possible. Some general guidelines. We should use consistent patterns in each layer. So if we decide to use, for example, the MVC pattern in the presentation layer, we should stick to it. We should be consistent. If we change the architecture for some reason in one layer and compared to another, there should be a very good reason to do so. So we should have a very good reason to use something else besides the MVC pattern. So if we use CQRS in the application layer, again, we should stick to it. I'm going to explain these patterns later. So for now, it doesn't matter if you're not familiar with them. So if you be consistent. If you decide on something, be consistent with it. Do not duplicate functionality. So for example, do not have a caching component in all layers. Do a general caching component or caching module which serves the caching responsibility of all other modules. You should prefer composition over inheritance. It's very complicated to create huge hierarchies. So the perfect scenario is to have composition and not a lot of inheritance here and there. Of course, you should work with the lead developer here because this is a detail. Work with him to or her to analyze the problem and consider the design. Establish a good code convention. Define the code style and preferably automate it. Again, you should work with the lead developer here because he may have some preferences, but establish a convention. It will be great if you can automate it to give you some errors and give you some problems around that. Layer guidelines. So some of the layer guidelines. First, you should have separate areas of concern. Each layer should have a single row and nothing more. Each layer shouldn't have anything else. Define communication between layers. It's the architect's job to understand how the different layers communicate with each other. So how does the presentation layer, for example, communicate with the business layer? How the customer layer, customer module communicate with the tickets module, for example, and so on and so on. What is the communication between the modules, the components, the layers? Use abstraction to loosely couple layers. Use interfaces for every communication available, and objects should not be tied to a particular platform or technology. That's also super important. Object should not be tied. Don't mix different types of components in a layer. Don't use various components. Don't use variety of components. If you decide to use certain components, stick to them. Be consistent. Keep in mind that I have a lot of practical examples later in the presentation, so bear with me. Even if you don't understand some of the concepts, we need to cover first the theoretical part. When we cover that, we are going to see a lot of examples, so bear with me. If you don't catch something, make sure to stick with the presentation and you will understand it. So the main important thing is to be consistent with components, to be consistent with data format, to be consistent with everything. That's super important because consistency actually makes flexibility and actually makes simplicity. That's important. Because if we want to have simple system, we shouldn't have different and many different parts in it. All the parts should be similar to the extent that's possible, of course. Different component guidelines is no component should rely on the internals of another component. Components should be black boxes. So if you want to use a component, you shouldn't be able to reach its internals. You shouldn't mix rows in a single component. For example, web controller should not have any business logic. That's a typical mistake because usually people in using the MVC pattern usually the controllers become quite messy and quite huge. Also, business layers should not have any presentational concerns. For example, presentational concerns in a typical web solution are HTTP concerns, web-related concerns. So the business layer should not understand anything related to the HTTP concepts. We should define clear contracts for components. All public methods and properties should be scoped in advance, again depending on the lead developer, but you should think about that. You should discuss that and decide whether to include it in your documentation. System-wide components should be abstracted from other layers. All cross-cutting concerns which are accessible in multiple layers should be extracted. This way it will be more simple to reuse them in future modules or components. So we should have a system-wide area of concern. And these were the main guidelines for creating architectures. We covered the tip of the iceberg here, but we understood what an architecture is. So I suggest we stop here on slide 74. We should continue next time. I'm going to post on Patreon when the next time is going to happen, and we're going to continue with unified modeling language. So far we covered the first 4 parts of the presentation. Why we need software architectures, the architect and the team, the different roles, what makes a great architect. We covered the soft skills required because they are super important. We covered what is software architecture in general, what are the main concepts, but it was very theoretical, so we need to cover a lot of theoretical things first before we start providing examples. But bear with me, we're going to cover a lot of examples. The book also has a lot of examples and I'm going to publish it too. I don't want to promise any deadline because I still have maybe 10 more pages to write in it, but still I'm going to publish it on Patreon, and you will have a lot of information in terms of theory and a lot of information in terms of practical examples. So I guess that you learn a lot from all these videos, all these lectures, and of course the book. So if you have any questions, you can ask me. It doesn't matter whether it will be on Patreon or whether it's going to be on some of the social media channels. It doesn't matter. I prefer Patreon, but as you see fit. So everyone who watched live today, thank you for being with me. I hope you enjoyed the lesson. Of course, again, it was more soft skills related, but we need to cover that because it's super important for any role above the senior developer, communication is huge and it's very important, and we should work on it. We should improve it. Good. So guys, thank you. Have a nice evening, and if you have any questions, just shoot me a message. Bye for now, and see you next time.